Now let us discuss what happens to an acid or a base in water. It means that, when an acid, or base, dissolves in water it shows acidic, or basic, behavior or not. First, we will discuss about acids in water. What happens to an acid when it dissolves in water? The acidic behavior of acids is due to the presence of hydrogen ions in them. The acids produce hydrogen ions only in the presence of water. So, in the absence of water, a substance will not form hydrogen ions, and it will not show its acidic behavior. For example, hydrogen chloride gas. Dry hydrogen chloride gas does not show acidic behavior, but when water is present, its acidic behavior is observed. Let us do an experiment to understand about acids' behavior in water. To do this experiment, we need to have the following apparatus: test tube, conical flask, delivery tube, and cork. The chemicals required for this experiment are solid sodium chloride, NaCl, concentrated sulfuric acid, concentrated H2SO4, dry blue litmus paper, moist, wet, blue litmus paper. We need to take few precautions while during this experiment, like if the climate is very humid, you will have to pass the gas produced through a guard tube, drying tube, containing calcium chloride to dry the gas. Acids are corrosive in nature. So, take dilute acids, it is one which contains much more of water in it. Let us start doing the experiment. Take 1 gram of solid sodium chloride, NaCl, in a clean and dry test tube. Take some concentrated sulfuric acid in conical flask and pour sulfuric acid in test tube. Fit a rubber cork with a small glass delivery tube to the mouth of test tube. Concentrated sulfuric acid reacts with sodium chloride to form hydrogen chloride gas. The hydrogen chloride gas starts coming out of the open end of the delivery tube. Hold a dry blue litmus paper in hydrogen chloride gas. We observe no change in the color of dry blue litmus paper. Hydrogen chloride gas is not showing acidic behavior in the absence of water. Now hold a moist or wet blue litmus paper in hydrogen chloride gas. What do we observe? We observe that the moist or wet blue litmus paper turns to red. Hydrogen chloride gas shows acidic behavior in the presence of water. So, we can conclude that the experiment shows that HCl gas does not show acidic behavior in the absence of water, but it shows acidic behavior in the presence of water. Now let us discuss in detail why dry hydrochloric acid is not showing acidic behavior in the absence of water. It is because dry HCl gas does not contain any hydrogen ions in it, so it does not show acidic behavior. Dry HCl gas does not change the color of dry litmus paper, because it has no hydrogen ions in it. However, when HCl gas dissolves in water, it forms hydrogen ions and shows acidic behavior. The chemical equation is HCl is dissolved in water, we get the H plus ions, plus Cl minus ions. Actually, hydrogen chloride gas first dissolves in water to form hydrochloric acid solution, which produces H plus and Cl minus ions. The separation of hydrogen ions from HCl molecules cannot occur in the absence of water. The separation of hydrogen ions from HCl molecules can occur only in the presence of water. So, HCl gas shows acidic behavior only in the presence of water. The HCl gas turns wet blue litmus paper to red, because it dissolves in the water present in wet litmus paper to form hydrogen ions, which can turn the blue litmus to red. Please note that the above reaction of dissolving HCl gas in water can also be written as follows. The chemical equation is HCl plus H2O gives H3O plus ions, plus Cl minus ions. Hydrogen ion is written in the form of hydronium ion. We have observed that Dry HCl gas does not change the color of dry blue litmus paper, because it has no hydrogen ions. HCl gas turns wet blue litmus paper to red, because it dissolves in the water present in wet litmus paper to form hydrogen ions. Now let's see the conclusions for this experiment. Acids do not show acidic behavior in the absence of water. Acids show acidic behavior in the presence of water. This experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of hydrogen ion from HCl molecules cannot occur in the absence of water. The chemical equation is HCl plus H2O gives H3O plus ions, plus Cl minus ions. Hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus hydrogen ions must always be shown as hydrogen ions, or hydronium ion. The chemical equation is H plus ions, plus H2O gives H3O plus ions. Now we shall see a base when dissolved in water. Most of the bases do not dissolve in water, but some bases dissolve in water. These are called alkalis. The base dissolved in water to produce hydroxide ions. Let us see few examples. Example 1. Sodium hydroxide dissolves in water to produce sodium and hydroxide ions in aqueous solution. The chemical equation is NaOH gives Na plus ions, plus OH minus ions. Example 2 is with potassium hydroxide. Potassium hydroxide dissolves in water to produce potassium and hydroxide ions in aqueous solution. The chemical equation is KOH gives K plus ions, plus OH minus ions. The third example is with magnesium hydroxide. Magnesium hydroxide dissolves in water to produce potassium and hydroxide ions in aqueous solution. The chemical equation is MgOH2 gives Mg2 plus ions, plus 2OH minus ions. Let us grab little information on neutralization reaction. In the above discussion, we identified that all acids generate H plus and all bases generate OH minus ions. So, neutralization reaction is acid plus base gives salt plus water. The chemical equation is HX plus MOH gives MX plus OH. Here, treat HX as an acid, and it will produce H plus ions, MOH as a base, and it will produce hydroxide ions. These H plus and OH minus ions combine to form water, and remaining ions in the solution, X and M, combine to form salt, MX. The chemical equation for water formation: H plus ions plus OH minus gives H2O.